Hello, ladies and gentlemen. Welcome to Deal or No Deal, Quantum Edition. Tonight, Mr. Unchained will take our wave function challenge. Are you ready, Django?
Yeah, let's do it.
Very good. First, let's go over the rules quickly. Notice that each of the cases has a wave function associated with it. This wave function corresponds to the probability that the case contains this value. Each case contains only one value. Notice that each case commutes with all the others, and all cases are entangled. With this in mind, you will first choose a case to be your own. After that, you will choose cases one by one to open up. Once you open a case, two things will happen. First, that value will be removed from the wave functions of all the other cases. And when this happens, don't forget to renormalize wave functions. Second, the banker will make you an offer. You must choose whether to accept this offer or open another case. If you're still playing until there's only your own case and one other case left, you have the option to switch your case or stay with your own. At this point, you will obtain the value inside that case. Do you understand? Very good. Let's begin. Please choose a case to be yours.
How about case B? Django, what are you doing? Dr. Schultz, what are you doing here? Oh, I'm so glad to see you. Can you please teach me ModFizz? I have no idea what's going on.
I should hope you should ask for help. You just chose a case with 5% probability of containing $1 million.
How do you figure that?
Well, you see,
given a wave function, you can determine the probability of a certain value occurring in that wave function using Dirac notation. For example, for your case B, this is the wave function that was given to you. You can calculate the probability of your case containing $1 million by putting 1 million as your state in a bra, and the bracket also contains the wave function for case B. When you do this, you substitute each of the values from the wave function into the ket portion of the bracket. So for example, this bracket contains 1 million and 1 million, which in Dirac notation simplifies to 1. However, you must go on to all of the other values too. So this is the bracket of 1 million and 1,000, which simplifies to 0. The same is true for 1 million and 1, 1 million and -1, and 1 million and -1,000, such that when you simplify, you get the normalization constant 1 over root 40 times 1 from this value times the coefficient of that value, which was root 2. When multiplied out is 2 over 40 or 1 over 20. That's how you know that your case has a 5% chance of containing $1 million. You can do that with a lot of different values too. For example, you can see here that I've calculated the probability of case A containing $1,000, the probability of case C containing -$1, and the probability of case D containing -$1,000.
Oh, I see. So based on those calculations, I should choose case C next.
yeah, do that.
Alright, guys, let's see what's in case C. That's $1! A very good start. Okay, now, let's see what the banker has to offer you. Yeah? Uh-huh. Okay. The banker has a great offer for you. He really doesn't want you to get the million, so he's offering you $294,000.
$294,000? No way, I still have a chance for $1 million. What do you think, Dr. Schultz?
Well, it's too early in the game to say anything definitive about the cases, but if you really want the million, you should probably keep going. Keep in mind, though, that if you reveal the million, your offer will instantly drop to less than $1,000.
Alright, no deal.
Very well. Now, pick another case to open.
Wow, based on the wave functions, I should pick case A next.
Well, hang on a minute. Remember to renormalize your wave functions.
Yeah, don't worry, I already renormalized it. Here, take a look at the calculations.
When we opened case C, it contained a value of $1. Since all of the cases commute and are entangled, we need to remove the value of 1 from each of the wave functions that are remaining. So for example, in case A, this was our original wave function. However, we need to remove a value of 1. When we do this, the total probabilities no longer add up to 1, which means we need to renormalize our wave function. The easiest way to do that is to remember that the total probabilities should add up to 1. In other words, a squared times each of the coefficients squared should be equal to 1. In that case, we get that a squared times 80 is equal to 1, meaning that a equals 1 over root 80, or equals 1 over 4 root 5, which gives us our new normalization constant, and we simply take the remaining values for our wave function to give us the new wave function for a. You can see a similar calculation here for b. Note that case D did not have 1 as a value. Therefore, its wave function remains the same.
Alright, let's see what's inside case A. That's -$1. Very nice job. You're one step closer to winning the million. Now, let's see what our banker has to say about this. Yeah? Uh-huh. Okay. The banker is really upset now. He wants you to take this offer and leave. He's giving you $450,000.
There's no way. I'm still hopeful for the $1 million.
Just play safe and be smart about it, alright? I don't want you to leave with nothing.
Alright. No deal.
Very well. And on we go. Please choose another case to open.
Well, check my math here. But because of the commuting nature and entanglement of the cases, these are the new wave functions. And based on these wave functions, I should choose case E because it has the lowest probability of having $1 million.
Yeah, Django, you're getting the hang of it now.
Very well. Let's open case E. $1,000. You're well on your way to $1 million. The banker's not going to be pleased about this. Let's see what he'll offer now. Yeah? Okay. Alright. The banker really hates you now. If he could just kick you off the show and take all of your money now. But he can't do that. So he's gonna offer you $750,000.
Wow, $750,000. That's a lot of money. I could turn my life around with that. My hopes and dreams could finally be unchained. If I continue, I have a chance of losing $1,000 or getting $1 million. This is a tough decision. But based on the new wave functions, probability is on my side. No deal.
Django, why did you do that? You could lose $1,000. That's $750,000. That's a lot of money.
No, don't worry. All I have to do is switch to case D. Based on these new probabilities, case D will have a higher chance of $1 million.
I've taught you well.
Are you sure you'd like to switch cases?
Yes, please switch the cases. Yay, I want $1 million.
Yes!
Yay.
Wait, hold on. The banker's calling again. I see. The banker's very displeased with you. In fact, he says he's gonna find your hide, Django.
With this $1 million, I hope to unchain the dreams of all my friends and family. I knew learning mod physics would have practical application. Congratulations, Janko. Live long and prosper.